Assalamualaikum warahmatullahi wabarakatuh. I am Mira Adrina binti Najib, number matric CF190204. Today I'm going to explain the introduction of this project. Okay, steel is an element of iron with typically a few 10% of carbon to improve its strength and fracture resistance compared to other form of iron. So there is a 5 main component in the steel frame. So the first one is tension member, is easily web and cord member in trusses. The second one is compression member, is made of column, strut and post. The third one is bending members, usually is beam, cadre, joist, spreader, purlin and so on. Okay, the fourth one is combined force member, is actually known as a beam column, subject to bending and axial compression. So the last one is connection. Connection is to tie all the components to act as one unit. Okay, and this project is designed a 3-story brace steel framing building. So as you can see in the slide, the left one is actually the front view of the building, the middle is the plan view of the building, and the right one is the structural layout plan of the building. Next.
Hi, my name is Nur Izin Izzati binti Muhammad Fauzi, number matric AF190063. I will explain about the loading. This is the loading assumption for our project. Metal deck equal to 0.5 kN per meter square, insulation 0.05 kN per meter square, ceiling and finishes 1.0 kN per meter square, variation 0.25 kN per meter square, and for the window is 0.7 kN per meter square. For the top quad, its GK permanent action is 0.5 plus 0.05 times 2.5 is equal to 1.375 kN per meter. And for the QK variable action, 0.25 times 2.5 equal to 0.625 kN per meter. And for the window WK equal to 0.75 times 2.5 equal to 1.875 kN per meter. And for the bottom chord, permanent action equal to 1.0 times 2.5 equal to 2.5 kN per meter. Next, this is the procedure how we calculate restraint beam in our project. First, we need to design load W 1.35 GK plus 1.5 QK. Next, design shear force VED and bending moment MED. Then we need to identify the class, which is cross-section classification, and then bending moment resistance. Next, checking the cross-section in plane bending. Next, shear resistance, and then verification for shear checking, then combine bending and shear. Last but not least, checking for deflection, which actual deflection must less than deflection limit, and lastly, resistance to transverse force.
I'm going to explain the fully restrained beam design for B1 and B3. First, the calculated plastic modulus is 2852.29 cm3. So based on the plastic modulus, we're going to try a size beam of 533 times 312 times 219 UKB. So as you can see in the table, this is the design result of the size of beam. So first one is classification of cross section. Both web and flange is in class 1. So the shear force resistance VED is smaller than VCRD, so the design is okay. For the shear buckling, the HW over TW is smaller than 72 strain over N, which is no need to be considered in the design. For the moment resistance, MED result is smaller than MCRD, so the moment resistance is okay also.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amila Fazim binti Zaidi, matric number AF190011. For my part is column design procedure. For the step 1, analysis of steel structure using step pro to determine the axial load, which is NED, and then step 2, the selection of the section. select the section of the channel of steel by calculating the area of the section using formula NED. And then from the area of the section, we calculate and we can determine the type, grade and the area of section that is suitable to be designed for the column. Step 3, cross-section classification of the section. Carry out the cross-section classification of the selection to eliminate local buckling. And then for the step 4, calculation of slenderness ratio of the steel section. First, calculate the slenderness ratio of the steel section using the formula. And then before the formula can be applied, the effective length of the column needs to be calculated. The formula is used to determine whether the slenderness ratio for the slenderness ratio less than 0.2, the column will be considered as stocky column. While for slenderness ratio more than 0.2, the column will be considered as slender column and buckling resistance checking need to be carried out for this column. Step 5, cross-section resistance checking. The cross-section resistance of the steel section must be checked and verified using the formula as below for NED divided by NCRD. Step 6, buckling resistance checking of column. First, determine alpha by first determining the required buckling curve from table 6.1 and then calculate by substituting in the value of alpha and lambda. Third, calculate the substituting in the value of G and lambda and determining the design buckling resistance of the member. And then check and verify the buckling resistance of the steel section using the formula as NED divided by NBRD. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akifan Hakim. My matrix number is AF190139. For my part, I will present about the roof truss design and procedure. So, this is the design procedure to calculate the design for the roof truss. First, we need to decide the geometry of the truss. The geometry of the truss has been given in the project instruction, and all I need to do is just insert the length of the truss and insert the number of members that the truss got. And after that, we need to input the action on the roof. That the action on the roof is, we assume the action and we input it into the step pro to do the analysis. After the analysis in step pro been calculated and done, we can calculate the purlin design, the design critical compression member and the critical tension member design. In the purlin design, first we need to determine the load, and we need after that we need to determine the moment. After we have determined the moment, we need to do a classification of section. Then we need to find the minimal MDZ and MDY. After that, we need to check for the deflection. If all the criteria is okay, then the proposed purlin design is okay to be used in this construction. For the design critical compression member and the critical member design, all the steps are the same, which is the determine required error, decide trial size, section classification, compression resistance and flexural buckling resistance. As we can see in this figure above, it shows how the load, section characteristic and other data will enter the program for analysis. After analyzing the truss, the resultant internal member force may be displayed. For example, in this table, these are the resultant internal force. To calculate the critical compression, we use the member number 9 and 16 because member number 9 is located at the end of the truss, and 16 also located at the end of the truss, so it receives the most compression at that part, so the critical compression is at that part. So we calculate the compression, the critical compression, by using the force value, internal force value that we got from start analysis. And for tension, we use the highest tension value, which is located at the middle of the truss, which is at member 20. This is the calculation that I do to calculate the design of the purlin. According to BS, the roof slope should be less than 30. So in this case, I assume the slope is 20. Then from the degree of the slope, we can obtain the QK or slope. And after that, we need to calculate the permanent load that acting on the slope, which is in this case is 1.5, and we need to multiply it with the QK slope that we obtained from the calculation above. Then after that, we need to calculate the WP and the WEL, which is the elastic. And after we have calculated, we can use, in conclusion, for purlin we use single angle 150 times 90 times 15, and for the WL required is 70, because the WL required is 77.7 cm.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afifah Rada binti Abdul Razak and my metric number is AF190013. And today I will be presenting about the connection for this group project, and for the type of connection that we will be using in this group project is welded connection. Okay, first of all, we will look at the beam to beam connection. Beam to beam connection from B1 to B2. And first of all, we need to check for single shear plan, and for beam size that we assume is 533 times by 312 times 219, universal beam and steel grade 275. For the one, if you want to calculate I section, the formula would be the height of the beam times by 80%, and the answer that we will get will be 448.24 millimeter. And the welded length would be the 1531.28 millimeter. As for the factor of safety that we will get from here, from this beam 1, would be the 0.41 kN per millimeter. And for the beam 2, the factor of safety that we will get is 0.20 kN per millimeter. And so after we get all that, we will insert it into the design shear strength of the weld. FVWD equal to FU times by root of 3 and beta W times by gamma M2. And the answer would be 228.22 kN per meter. And we will try the size of S, which is 6 mm weld fillet, and the FWRD would be 0.959 kN per meter, and which is bigger than 0.2 and 0.41 kN per millimeter, which is the factor of safety of both of the beam. Therefore, it is okay to use this. And next, for the total resistance, the minimum length required that we calculate is 654.33 mm, and the required length is 678.33 mm, but we assume the length to be 700 mm. And the total resistance of weld would be the required length times by the FWRD that we get just now. Therefore, it will be 671.3 kN, and it is bigger than 627.5 kN. Therefore, it is okay. And for the detailing of the connection, and this would be the detailing. The welded length would be over here, would be along the I section beam here, and also the here. Okay. And this is the front view of the weld fillet, and this is the plan view. Okay, next would be the beam to column connection from B2 to C1. And as usual, we will calculate the checking for single shear plan, and the beam size is also 533 times 312 times 219. And the VED is 313.75 kN. As for this factor of safety for this beam to column would be the 0.20 kN per millimeter, and for the UC column we will get is the 0.34 kilonewton per millimeter. After we to calculate this Fs, we will use the formula of P over welded length per millimeter length, and the welded length here we get from here, which is 256.3 times by 2 plus 208.24 times 2, and we will get the value of 9 to 9.08 millimeter. After that, we will calculate the design shear strength of the weld, and the value that we will get will be the 228.22 Newton per millimeter. And we will try the S equal to 8 millimeter weld fillet, and we will insert into this formula FWRD equal to FVWD times by A. A is the one that we calculate here, and it would be the answer of, we will get the answer of 1.278 kilonewton per millimeter, which is bigger than 0.20 and 0.34 that we calculated just now, which is the factor of safety from the previous slide. And next, for the total resistance that we will get, to get the total resistance, we will need the value of minimum length required and the required length, and for the total resistant weld that we will get over here is 702.9 kilonewton, which is bigger than 627.5 kilonewton, therefore it is okay. For the beam to column connection from B3 to C2, also the same, we will check the checking for single shear plane and direct shear for the I section value, welded length, factor of safety that we will get from this beam 3 to column 2 is 0.41 kilonewton per millimeter, and for the UC column, the factor of safety is 0.68 kilonewton per millimeter. And the design, we need to calculate the design shear strength of the steel FWRD, and the answer would be 228.22 kilonewton Newton per millimeter. And we will try the S size of 8 millimeter weld fillet, and to calculate the FWRD is FVWD that we get from the top here, and we will insert it, and we will times it by the 0.7s that we get here, which is 5.6, and the answer would be 1278.03 Newton per millimeter. But we want the answer in kilonewton per millimeter, so it will be 1.278 kilonewton per millimeter, and this value is bigger than 0.41 factor of safety from the beam, and also 0.68 kilonewton per millimeter is the factor of safety from the column. And total resistance for this beam to column connection would be the 702.9 kilonewton, and it is bigger than 627.5 kilonewton, therefore it is okay. And this is the detailing of the connection of the beam to column connection, and the welded part will be along all of the I section beam, and this is the steel column of size 254 times 251, and this is the front view of the weld fillet, and this is the plan view. The welded side will be over here, between steel beam and the column of the section of the connection. And I think that's all from me. Thank you.